read these two. Also, I noticed that the graph is increasing or decreasing. Right. So what does that say to me or to us? That the base must be, they're all positive. Remember, the base can be either between 0 and 1, tiny, or between 1 and infinity. It cannot be 0, it cannot be 1, it cannot be negative. Yes, it has to be greater than 1 because the function is increasing. So when the function is increasing, the base has to be greater than 1. Perfect. Okay, so keep that in mind, that we are looking for a function with a base greater than 1 that passes through these points. However, the first point is useless. Why? Let's put it in. So what does this say? It says that f of 0 is 1. Let me explain why this is useless. A to 0 is 1. And that doesn't tell me anything about a. Just remember, a cannot be 0. We know that. So this equation does not give me any information about a. This will be true for any a that is not 0.
So what's square equals 9?
So yes. So then I have to use the other one, in which first I have to write that f of 2 is 9. That's what the point is telling me. That when x is 2, y is 9. We agree? Right. So then now I change this using this. So what do I write? But now I know how to solve this. It's a quadratic equation. How many solutions will I have? Will I get? Right. So I will take the square root and I have to write a equals. If I forget something very important on the right-hand side, then I mess up the problem. Plus or minus. However, I have to cross it out. I'm showing my professor that I know how to take the square root, but I cannot accept the negative because I know the base cannot be a negative number. So I'll say only x, I'm sorry, not x, a equals 3. Therefore, the exponential function is definitely 3 raised to x. Is this clear? Every step? Very good. Is there anything else? 4-1, 4-2, anything else?
Is it okay we go back to 7.5?
Yes, of course, yes. 7.5, yes. Do I need a book or can I get the problem from you? I need a book?
Have a
Okay, I opened at 7.5.
Yeah.
I'm ready.
So number 13.
Yes,
So
529. 13, I see it. Sine theta minus 1 equals cosine theta. And we're asked to solve the given equation. Sine theta minus 1 equals cosine theta. Okay. Now, this particular equation has two trig equations in it, two trig functions in it. It has sine and cosine. Now, if I try to change one into the other, it's not going to work. I can't. You don't have to write this. But sine theta equals plus or minus the square root of 1 minus cosine square theta. I can't put plus or minus in an equation like this. If I try to replace cosine in terms of sine, I will get the same thing, but with plus or minus, which I cannot do. So my only chance here is to square both sides. And you can say, wait a minute, we square both sides when we solve radical equations, not when you solve a trig equation. True. So remember, when I square both sides, I am allowed to square both sides, but there is a problem with the mechanism. I always have to go back and do what?
Sure.
Right. So now the question is, why would I square both sides? Here's why. If I square this and I square this, then the left-hand side is sine squared theta minus 2 sine theta plus 1. And the right-hand side becomes cosine squared theta. And therefore, you're welcome. Therefore, now I'm in business. Why? I can change this into 1 minus sine squared. But remember, I squared both sides, and at the end of the day, I have to go back and check whatever solutions I get back in the original problem. So now I will replace this by 1 minus sine squared. So therefore, the equation becomes sine squared theta minus 2 sine theta plus 1 equals 1 minus sine squared theta. Are we okay so far? Yes? Okay. This and this will go away when I subtract 1 from both sides. Of course, I will move sine squared to the other side, and I have 2 sine squared theta minus 2 sine theta equals 0. I love everything I see now, right? Because 2 will go away, and I will factor out sine theta. Would you agree? Divide both sides by 2, which is fine. And then I will factor out sine theta, and I get 1 minus sine theta. And from here, I have 2 options. Let's back up for a moment. Is this clear? I could not change sine into cosine because both of them had power 1. I could not change cosine into sine for the same reason. Both of them had power 1. And I had no way of replacing one with the other. But squaring both sides, which is a legitimate method, however, it comes with checking, mandatory. Then right now I have 2 options. I have that sine theta equals 0 or sine theta equals 1. Is this okay so far? Oh, I'm sorry. I'm sorry. I don't know why I wrote that. Sine theta minus 1. Okay, so we see the solutions are sine theta equals 0 and sine theta equals 1. Any questions on that? So then from the first one, I go back to the unit circle. In order to solve the equation sine theta equals 0, I go back to the unit circle. I remember that sine is measured on the y-axis. And where is sine 0? This is 1. Because it's measured on the y-axis, this is 1 and this is negative 1. Yes, so here and here. So there are 2 options. So theta equals 0 plus 2 pi k, or theta equals pi plus 2 pi k. You could condense them into pi k if you wanted.
So you factor out sine theta?
Yes.
So you get sine theta?
I divided both sides by 2, so I have sine squared minus sine theta. I factor out sine theta, and I have sine theta minus 1.
Yeah, I can see it.
Oh yeah, I don't care for numbers. I can divide both sides by anything that is non-zero.
Okay.
Yeah. And finally, we have to solve the equation. Sine theta equals 1. And sine theta equals 1 has only one option. So theta is right here. Sine is measured on the y-axis, and it's 1 only here. So it's pi over 2 plus 2 pi k. Now I have to go back and check. It's sufficient to check one of them. I have to check 0 back in the original problem. I have to check pi back in the original problem. And I have to check pi over 2. I don't need to check more than when k is 0. If it works when k is 0, it will work for all the other ones. Okay, so back to the original problem, which was sine theta minus 1 equals cosine theta. Ready? We are checking three numbers. I'm checking 0. So if this is 0 and this is 0, how much is sine 0? Yes, because sine is measured on the y-axis. 0 minus 1, the left-hand side is negative 1. How much is cosine 0? Cosine is measured on the x-axis. No, cosine 0 is only one number. At 0 degrees or 0 radians. Right here, at this point, how much is cosine? Cosine is measured on the x-axis. How much is this? So it's 1. It's the measure between this point and this point because it's measured on the x-axis. Cosine is measured on the x-axis. So it's 1. Is negative 1 the same with 1? No. Now I'm checking pi. Cosine, sine pi. Sine is measured on the y-axis. Sine pi is 0. 0 minus 1. The left-hand side is negative 1. How much is cosine pi? Cosine is measured on the x-axis. Negative 1. Is this correct? I'm going to say yes. Last one. I have to check for pi over 2. So one more time, the equation is, I have to copy it, sine theta minus 1 equals cosine theta. So now pi over 2 and pi over 2. So sine pi over 2. Sine is measured on the y-axis. How much is sine here? 1. So the left-hand side is 1 minus 1. Cosine theta, cosine pi over 2. How much is the x value here? 0. Is this true?
Yeah.
Yes. So these are the only two solutions. Well, infinitely many because of k. But these are the only two options. Pi and pi over 2. Is this better? Very good question. Thank you. Thank you for asking. One more time, why did we check solutions and then we didn't check solutions in other trig equations? Because we square both sides. When we square both sides, we cannot guarantee that the solutions work in the original problem. Excellent question. Thank you. Very good. Can we go back then to 4.3? Yes? Okay. So we are at the stage in which we want to practice that very important concept. And then I would like to look at some transformations with log functions. Ready? On page 322, I would like to look, please choose anything you want. I'm looking at problems 7 through 12. On page 322. So I'm looking at problem 8b. Log base 2 of 1 over 8 is negative 3. Of course, I copied 9. No worries. Sorry about that. So it's 9b. The question, 9b, sorry about that. Express the equation in exponential form. Express the equation in exponential form. Exactly. We write the equivalency symbol, which means this implies this, and this implies this, back and forth. 2 raised to negative 3 equals 1 over 8. Very good. Okay, let's go backwards now. Let's say 16a. 4 raised to negative 3 halves equals 0.125. Notice where I put it. I put it on the right-hand side because this is the exponential equation. This is the exponential, and this is the log. This is the exponential, and now I want the log. equation. And remember, write log, and we are going to have to look for, we are looking for three numbers. One that is the base right here. One that is the number we raise the base to right here. And this is x. Always start with the base. What is the base? Right. What do I raise it to? Right. 4 raised to negative 3/2 is what number? Exactly. 0.125. Very good. Let's do another one of like this. Let's say 17a. And we have e to the x equals 2. I recommend write it on the right-hand side if you want to keep them in this order. I prefer that. It's up to you. Now the left-hand side has to have a log. Which log? Which base? Yes. And if I write ln, there is no need to write e. So this is log base e, right? So now I need a number here and a number here. What do I raise e to? E raised to, right, equals 2. So I have the exponential equation on the right, the log equation on the left. I would like to evaluate an expression. Please choose 19 through 28. (19 through 28). Yes, now we can talk about that. So 25, we have 2 raised to log base 2 of 37. It says evaluate the expression. We don't know what this is. Okay? Okay. So now here's my question. I see a base which is 2. And I see a power, right? So this is going to be on the right-hand side, 2 raised to log base 2 of 37. And it's a number that I have no idea what it is. But this is an exponential expression. 2 raised to a power, 2 raised to a power equals x. Okay. I want to write the equivalency. I want to change this exponential equation that I just created. I created it how? I just said 2 to this base is a number. I don't know what number. So I created an exponential equation by saying I don't know what this is. That's all I'm saying. Now I want to change this exponential equation to a log equation. So remember, we have log, we have to have a base, we have to have something after the equal symbol, a number here or a quantity, and a number or a quantity here. What is the base? 2. What do I raise it to? What should I put here? Yes? Very good. Excellent. And what goes in here? Now let's look at this expression, this logarithmic equation. What am I missing? And how much is x? I have on one side log base 2. I have on the other side log base 2. Right? Same. I'm not canceling out. That's a very good question, very good idea. But I'm not canceling out. I have to think. This is a one-to-one function. What does that mean? I cannot find 2 different x values that will give us the same result. So there is only one possibility for x. What is that possibility? It must be 37. Only log base 2 of 37 is log base 2 of 37. Only log base 2 of 37 equals log base 2 of 37. Right? Clear? So then what is the answer? 37. And now I can explain, or I should ask you to think about it, and maybe this is not, I have to be honest, this particular property of the log is not necessary for Calc 1, but it is for Calc 2. It's a very important property. Very important property. So, I'm not going to super emphasize it, but it is a very important property for Calc 2. So here's the property. Base A raised to log base A of x will always equal as long as these two bases are the same. If they're not the same, you cannot write what? You cannot write x if bases are not the same. So let me give another example. What about this? E raised to natural log of x to the third. What do you think this is? Right, because this base and the base of the log are the same. What is the base of this log? Right, that's why the answer is x to the third. However, 5 raised to log base 3 of x does not equal x, because 5 and 3 are not the same base. Good. So let's simplify another. Please choose another between 19 to 28 so we can move on. Okay, 28b. Log base 4 of 1/2. Okay, well, I have no idea what this is. I'm going to call it y. But this is equivalent to what? Yes? Yes? Very good. This is an exponential equation. We will discuss more details about this. Now, when I look at this exponential equation, I ask myself, can I present both sides with the same base? And the answer is yes. What is the only option for 4? A base raised to what? What base and what power? 2 squared raised to y. Good. Is there another way of writing 1/2 with the same base? Yes. 2 raised to instead of 1/2, I want to write 2 raised to a power. Yes? -2 will be 1 over 2 squared. Exactly. Excellent. So now the left-hand side, I copy the base. What happens to the exponents? I'm multiplying because I raised to a power. This is not 2 squared times 2 to y, in which I copy the base and add the exponents. So here I copy the base. What happens to the exponents? Right. So this is 2y equals 2 to -1. Now these are two equal numbers and they have the same base. What has to happen to their exponents? 2 raised to 2y equals 2 raised to -1. So what? Say it again?
You said that was equation.
Exactly. Exactly. 2y equals -1. So how much is y? That's it. So this is the answer right here. Log base 4 of 1/2 equals -1/2. Okay. 29 to 36, please choose. 29 through 36. Any questions on this problem? Okay, I get to choose then? Okay, 32b. I strongly recommend please do your homework from this chapter as diligently as you did the entire semester, okay? Please don't forget that, okay? So you can ask questions. So log base 4 of x equals 2. Use the definition of the log function to find x. or in other words, the most important property or concept in this chapter. That's the foundation of everything we talk about in chapter 4. So what will you write?
4 squared.
4 squared equals? Good, which means x equals 16. So which function are we really talking about? The function is log base 4 of x, and we are talking about x equals 16. Very good, excellent. Would you like to choose another, or we move on to sketch the graph or identify a graph? Yes? 23b, very good. You said 23?
Yeah.
23, yes. That's a different one. It's not from 29 to 36, but let's do it.
Yeah.
So you want B?
Yeah.
Okay. They shouldn't be writing log base 10. They should be writing just this. Yes. So this is 23b. Good. So again, I have no clue what this is. I'm going to call it y. But I know that there is an equivalency between this log equation and the exponential equation. And which exponential equation are we talking about? Yes. 10 raised to y equals the square root of 10. The left-hand side, I cannot do anything to it. But the right-hand side, I'm hoping that I can rewrite it with the same base. What same base? What base? When I say the same base, it has to be base 10. If it's not the same base, there is a procedure, but we haven't gotten to it yet. So the square root of 10 is the same with 10 raised to, indeed. Therefore, y must be, that's it. Let's also look at 36b, in which we have log base x of 3 equals 1/3. Same question, we're asked to find x. I have no idea what this is, but I know I can easily, quickly convert it into what? Yes. Yes? Equals? Good. But I know what x to 1/3 is. Is there another way of writing x to 1/3? Exactly. And now I think, the cube root of is 3. That's it. Or you cube both sides to eliminate the power, 1/3, and you get x equals 27. And yes, you can say, wait a minute, you raise both sides to the third power, go back and check. True. But the odd powers always work. Good. Okay, so let's look at a few transformations using log functions now. Okay, so let's graph f of x. I'm making this up now for a second. Let's say log of x minus 1 plus 4. What did we say about the exponential function? Friendly or not friendly? Friendly. Exists everywhere, no problems. What did we say about the log function? Not friendly. We said log function, if you remember, log is defined on 0 to infinity, and it will come back with everything. But it's defined on 0 to infinity. What is log applied to right now? It's not applied to x. But log is applied to x minus 1. Therefore, x minus 1 has to be a number here. So I have to write greater than 0. Solve this inequality, x greater than 1. What is the domain of this function? Exactly. The domain is 1 to infinity. Perfect. Okay. So now I want to graph this function, but first I want to identify the base. What is the base function for log of x minus 1 minus 4? Yes, but the base function is f of x equals log x. First step, there is one transformation on the base function. Which transformation is on the base function? Exactly. That's why we already know where it's going. How do I know where it's going? Right. So log of x minus 1, right 1. Final transformation, after I move it right 1, and I know what else is moving with it. The vertical asymptote is moving with it. The original vertical asymptote is x equals 0, right? Because remember, the exponential function has a horizontal asymptote. Its inverse has to have a vertical asymptote. Good. So then up 4, correct? Okay. So we have log of x minus 1 plus 4, which is up 4. Transformations have to be presented in this order, okay? So let's graph the base function. Since the base is 10, will this function be increasing on all its domain or decreasing on all its domain? Increasing. Very good. So first I have to graph log base 10 of x. Log or common log x, which we know has a vertical asymptote at x equals 0. This is an overkill, but I will present it so we don't forget. X equals 0, a vertical asymptote. The first function you gave me, you said 1 to the right. Fine. So right here, this is 1 comma 0. So this is the vertical asymptote for number 2. And this point from 1 comma 0 will have to be shifted where? Yes, 2 comma 0. So here's the graph of log x minus 1. Final transformation, what do I do with this graph of log x minus 1? You already told me. Now, where does that point move? So this point is at 1 comma 0. If we want to shift the graph up 4, where will this point move? So this graph, light green graph, has to move up 4. So this point from 2 comma 0 will move at 2 comma 4. So this is log x minus 1 plus 4. Any questions? Now the concept of domain here is very important. One more time, domain. Look at how many questions we have on domain of log functions. 63 through 68.
Sorry, but the vertical asymptote doesn't move anywhere.
When we shift, if it's a vertical asymptote and we shift, nothing moves. But if it's a vertical asymptote, it moves with the graph. Perfect. Good. 63 to 68. Okay, let's start with 64. F of x equals log base 5 of 8 minus 2x. Bless you. In this question, we are only asked to find the domain, nothing else. What do I have to write in order to find the domain for this function? Log does not exist if this is not what? Greater than 0. 8 minus 2x greater than 0. Linear inequality, move 8 to the other side. Divide both sides by -2. What do I have to do when I divide both sides by -2? Yes, of the inequality. Very good. So then the domain of this function is? Right. So in interval notation, less than 4. Very good. That's the domain. Okay, now let's look at 66. Any questions on 64? G of x equals natural log of x minus x squared. I have to find the domain of this function. What do I have to write? Exactly. Never equal to. I didn't say you said that, but I just want to remind you. This is very similar to the square root, but the square root is allowed. 0 is allowed under the square root. Very similar, but not in the case of log because it has a vertical asymptote at 0. Perfect. What type of inequality is this and how do I solve it? Right. So I cannot move terms around. What do I have to do? Yes, excellent. Then, say it again. Right, but I have a negative leading coefficient that bothers me. Yes, multiply both sides by -1. What do I do when I multiply both sides by -1? Very good. And now, yes, I have to do what? Yes, I have to pull out the greatest common factor, which is x. And then I get x minus 1. So what do I have to do then? Remember, this was in section 1.7, a long time ago.
So you said x is less than 0 and x minus 1?
No. I have to study the sign of this expression. And if you like to use the chart that I showed you, fine. If you don't like to use the chart, study the sign in any other way. But please do not write what Shane just told us to do. It's a perfect example of what not to do. Thank you. Exactly. It's a collaboration. X is the variable in the problem where I plug in numbers. This x is the first factor. This one is the second factor, and this is what I'm interested in. Where is x 0? Where is x minus 1, 0? And I have to put these numbers in ascending order. Does it ring a bell now? 0 and 1. Where is the 0 for x again? Good. Where is the 0 for x minus 1? Right? And the product is 0. Always establish the zeros first for everything before you put the signs in. And what happens to the product when x is 0? What happens to the product when x is 1? Good. Now I see that both are linear functions with the same slope, positive slope. I don't have to worry about anything. I just fill it in. Negative before it's 0, positive afterwards. Negative before it's 0, positive afterwards. So then, when I multiply two negative numbers, I get. When I multiply a positive and a negative, I get. And when I multiply two positives, I get. Good. And only now I look at this. Which sign do I want? I want negative. Is the product ever negative? And then what is the domain of the function?
0 to 1.
Right. Let's look at this. The calculator will not graph the asymptotes though. Of course the function, oops, I'm not prepared. Sorry. So we know at x equals 0 and at x equals 1, the function will have vertical asymptotes. So natural log, it was x minus x squared, x minus x squared, close the parenthesis. And what else do I want? Since I know it's between 0 and 1, I'm going to change the viewing window between -2 and 3. And between, oh, I already see the graph, between -4, -5, and +5. I see what I did. -5 and 5. And graph. We know the graph doesn't end here. It goes all the way. So let me go back and just do this. I want y minimum -20 with a scale of 5. Okay, here it is. We know that this is incorrect. We know that the graph continues to get closer and closer to the vertical asymptote, and here and here. It doesn't start at this point, it doesn't end at this point. Okay? Be very careful. So indeed, it shows that we were correct with the domain. Okay, so let's look at one more, like 67. This is crucial. Finding domains of functions and function like log, super important. 67. Natural log x plus natural log 2 minus x. Okay, this is very similar to something we did in chapter 2, in which we said, okay, I want to add two functions. If they don't have a blah, blah, blah domain, I won't be able to. What word am I looking for? Nope. If they don't have a, in other words, I'm saying if one is defined here and one is defined here.
Oh, common.
Thank you. So I need to find the common domain. Exactly. I won't be able to add two functions that are not defined on at least the piece that it's common. If they have no common domain, one is in Australia and one is in Ohio, I can't add them. So, what is the condition or the restriction for this function? X must be, that's it. What is the restriction or condition for the other function? Greater than 0. These two conditions will have to be intersected. If these two conditions do not have any x in common, this function will never exist for any x value. So the function will exist only if these two conditions have a common territory. So first, this is solved already, but this one, -x greater than -2, I move 2 to the other side, of course, and then I have to divide or multiply. In this case, it's the same thing. Both sides by. Good. And what do I have to do when I multiply both sides by? I flip from greater than to less than. So now this is solved. On the real line, I have -∞, infinity, 0 in the middle. I graph the first interval between 0 and infinity with a parenthesis. And I graph the second interval, also with a parenthesis, between -∞ and 2. Would we agree? Okay, so no need for units here. We're only graphing to establish what's happening. If green overlaps with red, or vice versa, then this function exists only for the overlap. If there is no overlap, this function cannot be created. It doesn't exist, it's useless.
So the domain is 0 to 2.
That's it. The domain is indeed 0 to 2. Any questions? Any questions? I would like to look at a word problem. As I mentioned, this is full. This chapter is full of word problems. Anything you want. Absorption of light, carbon dating, bacteria colony, investment, charging a battery, difficulty of a task. Please choose. Which one?
86.
86. So let's look at 86. Absorption of light. Let me see what I'm with time here. Okay, I still have time. So 86 on page 324. Spectrometer measures the concentration of a sample dissolved in water by shining a light through it and recording the amount of light that emerges. In other words, if we know the amount of light that is absorbed, we can calculate the concentration of the sample. For a certain substance, the concentration in moles per liter is found by using the formula C equals negative 2500 natural log of I divided by I sub 0, where I sub 0 is the intensity of the incident light and I is the intensity of light that emerges. Find the concentration of the substance if the intensity I, so I is 70% of I0. This is very important. I is 70% of I0. So obviously the variable is I, so this should be C of I. I is a constant, I0 is a constant. So that should be clear. The problem should emphasize that. So I is 70% of I0. I would like a mathematical equation or explanation or something that replaces those words, that statement, in a mathematical way. When we say is, we don't multiply and we don't divide. Exactly. We don't use 70%, but we use perfect. Now I want, this is a key word. Which operation is this? Exactly. That's all I needed. So we are asked to find what happens when I is 0.7 of I0. So then C of 0.7 times I0. How do I write that? Equals negative 2500 natural log, and now what? What goes to the top? Exactly. 0.7 I0 over I0. Exactly, because they are factors, both of them, top and bottom. Good. Now all I have to do is just plug it in. I have no idea what that is. So natural log, I'm sorry, I meant to write negative 2500 times natural log of 0.7. Now a question for you. When we graph natural log, it crosses the x-axis where? 1, 0, right? 1, 0. So at 0.7, natural log will be a negative number or a positive number? Remember the graph? And it crosses here at 1. At 0.7, negative. Beyond 1, okay, let's look at the graph one more time, because I would like you to be aware of this. This is very important. So this is the graph of natural log, correct? And this is 1. So at 3, it will be whatever, but a positive number. At 0.7, it will be whatever, but what type of number? Is that clear? Is that clear? Exactly. Good. So now, since natural log of 0.7 will be times a negative number in front, correct. So I'm going to say 892. So the concentration in moles per liter. So the answer is 8, or to be, it doesn't say to round up or not. So I'm going to, in that case, I'm going to say 687 in mole. 891.687 moles per liter. All these problems are very doable. Please read the others, and if you have any questions, let me know. Moving on to laws of logs. This function is an amazing function.